Hey there, 8th graders. Welcome. Get ready because today we're going to look at the universe through a totally new lens. Have you ever noticed that literally everything around us, from the chemistry happening in a laboratory to the daily choices we make in our own lives, is built on a foundation of order? Well, today we are exploring the fascinating science of matter classifications. We're going to look at how different substances combine, how they interact, and how understanding these tiny, invisible structures actually helps us make sense of the world on a much, much larger scale. So grab your notebooks because this is going to be a fantastic journey into the hidden rules that hold our physical world together. Okay, let's dive right into this. Here is our roadmap for the explainer today. We'll start with part 1, the foundation of order. Part 2, homogeneous versus heterogeneous. Part 3, everyday mixture examples. Part 4, why uniformity actually matters. And finally, Part 5, science, morality, and peace. All right, kicking things off with Section 1, the foundation of order. Now, before we can even begin to talk about the chemistry of mixtures, beakers, and molecules, we've got to look at the baseline rule of the universe. 1 Corinthians 14:33 states, God is not a God of disorder, but of peace. I absolutely love starting our science lessons right here. Why? Because science isn't just about randomly mixing things together to see what explodes. Fundamentally, science is the passionate pursuit of discovering this exact order. We're looking for the peace and the rules governing matter, rather than just seeing a universe full of random chaos. When you understand that matter follows specific peaceful rules, everything else just starts to make sense. Moving right along to Section 2. Homogeneous versus heterogeneous. Grab your pens because you'll want to write these core definitions down. Let's start with the what. A homogeneous mixture is a mixture that is uniform in composition throughout. Now, the absolute biggest clue here is that you cannot see the different parts. It looks like one single continuous substance. Think about salt water. Once the salt is completely dissolved in the water, you can't see the salt crystals anymore, right? It just looks like plain water. The air we breathe is another great example. It's a mix of oxygen, nitrogen, and other gases, but it's completely invisible and uniform. Even something as simple as a glass of milk appears to be perfectly uniform when you pour it out. But on the flip side, we have the heterogeneous mixture. This is a mixture that has visibly different substances or phases. And phases just means distinct parts that you can easily spot with your own eyes. Imagine a bowl of thick vegetable soup. You can clearly see the carrots, the peas, the broth. They definitely don't blend into one invisible superliquid. Or think of trail mix, where you can easily pick out the peanuts, the raisins, and the chocolate chips. Even a solid chunk of granite rock, with its speckles of quartz and different minerals, is a perfect textbook example of a heterogeneous mixture. You can see the chaos, the different pieces just holding their own ground. Comparing them side by side really cements this in our minds. On the left, we've got homogeneous. Uniform, orderly, the parts are entirely unseen. And on the right, heterogeneous, visibly different parts and phases. Just keep this simple comparison in your head. Uniform versus visibly different. Unseen parts versus visible parts. It's a very simple rule, but honestly, it is the master key to unlocking how we classify all of the matter around us. All right, Section 3, everyday mixture examples. It is time to test these concepts out in the real world. Let's step out of the textbook and into our very own kitchen laboratory to see how this works with things you probably eat and drink every single day. Think about sweet tea. Its classification is homogeneous, and the why is the most important part here. The sugar dissolves completely into the tea, making every single sip taste exactly the same. It is perfectly uniform. On the other hand, think about a big slice of pizza. Its classification is heterogeneous because you can easily see and pick off the pepperoni, the cheese, the crust, and the peppers separately. It has visibly different parts. Pretty straightforward so far, right? But wait, I have a bit of a trick question for you. Think about a tall, cold glass of orange juice with pulp. Is it homogeneous or heterogeneous? I want you to really think about this for a second before we move on. It's a liquid. It looks mostly orange. What do you think? Well, here's the answer. Orange juice with pulp is a tricky heterogeneous mixture. So the crucial point is this. Orange juice might look uniform initially when you first pour it, but if you leave that glass sitting on the counter for a while, what happens? Yep, the pulp settles right at the bottom. Because those visibly different phases separate out over time, it's heterogeneous. This just goes to show how some mixtures can completely deceive the eye until you look really closely at how they actually behave. Which brings us to Section 4. Why uniformity actually matters. Now, you might be sitting there asking, why do scientists even care about putting mixtures into these two categories? Like, really, why does it matter if my juice has pulp or not? Well, the stakes are actually incredibly high. Uniformity isn't just a vocabulary word for a quiz. It literally governs the real world. Knowing the classification determines the exact method scientists use to separate materials. It predicts how a chemical will behave when you use it. Think about engineering and medicine for a second. The safety and effectiveness of a life-saving liquid medication completely depend on it being a perfectly uniform homogeneous mixture so that every single drop has the right amount of medicine. It ensures quality in cooking. It even helps scientists formulate better everyday materials, like engineering paints that go on the wall smoothly and don't separate while sitting in the can. So yeah, uniformity dictates safety, structural integrity, and quality across the board. Let's do a quick classroom checkpoint and run through your homework. Questions 1, 2, and 3 ask you to define homogeneous, define heterogeneous, and to give one example of each. You should absolutely breeze through those by now. But take a close look at question 4. Explain why milk appears uniform but is technically heterogeneous. Okay, here's a massive hint for you. Remember our orange juice trick question? Milk is exactly the same kind of trick. While it looks like a uniform homogeneous mixture to the naked eye, under a microscope or if it's left raw and unhomogenized, the fat and cream will visibly separate from the liquid. It's technically heterogeneous. Keep that in your back pocket for question 5, which asks how to make a heterogeneous mixture more uniform. And finally, section 5, science, morality, and peace. This brilliantly illustrates our final point today, as we connect the scientific order of the mixtures we've been talking about straight back to the order inside your own mind. This brings us to the core philosophy of the Godly Learners series. The central idea is simply this: education without biblical morality will hurt. Think about what we just learned about mixtures. If an engineer creates a chaotic, unstable mixture for a bridge, that bridge fails. In the exact same way, being incredibly book smart without having moral order in your life leads to chaotic choices that ruin the structure of your life. Knowledge is power, sure, but without the moral compass to guide it, that power can be pretty destructive. Romans 8:67 offers this beautiful promise, peace of mind to everyone who keeps his or her mind spiritual. This isn't just some ancient idea. It's something we see consistently as people engage with this material. Bringing spiritual order into your education is the ultimate way to guarantee that your mind doesn't become a chaotic, heterogeneous mess of conflicting ideas. It brings that uniform, peaceful order we talked about at the very beginning of this explainer directly into your heart and mind. So, I really want to leave you with this final, powerful thought to chew on today. What is the actual point of being smart and supposedly educated if you just continue making bad choices that end up hurting you and others? True education isn't just about knowing how to classify matter. It's about knowing how to govern your own choices. I highly encourage you to pursue both scientific knowledge and biblical wisdom with the exact same passion. Thank you so much for joining me today, 8th graders. Keep learning, keep asking those big questions, and I will see you in the next explainer.